welcome back to Fuzz Lab. Today I'd like to tell you a little bit about the power supply I made. I've seen these products commercially available. They have the Voodoo Labs pedal power. It's actually kind of expensive. The idea behind these devices is if you're a musician, you're using a bunch of pedals for your system. Each one of those will have its own 9-volt adapter, which you get a lot of clutter and sometimes problems with hum. So you can get one of these units and there's one power input and then there's many power outputs. So it takes a larger voltage, drops it down, regulates it to 9 volts, which is what most of the guitar pedals work on. Here, I work with all kinds of voltages, and my old approach was I have a couple of boxes, large, full of adapters, and I had certain favorite ones that they were quiet when you ran them through your system with the guitar. They didn't hum, and especially with those my favorite adapters, the wire would break. And if you have that problem, you can look back in my older videos. I have a video called AC Adapter Repair where I can show you how to remedy that with a couple of tools. Back to this idea, when I built my new workbench I call Fuzz Lab, initially I was running adapters and I had to kind of get up, and so I was looking around and I had, aware of these expensive brick power supplies. And I noticed that when I was ordering my parts, they had these things called voltage regulators. They were little small guys. There's a screw hole, you can screw it down, like for heat, maybe it gets hot. There's 3 wires coming off of it. So the idea is, it'd be, let's say it's a 9-volt voltage regulator. So you have to put at least two more volts than 9, so 11, 12, anything up past 11 coming in, hits the first wire, the second wire goes to the ground, and then the third wire is the output. So it seems simple enough. So anyway, parts were cheap. I think I got them for like 50 cents a piece. I ordered a whole bunch of these voltage regulators, and 3, 5, 6, all different varieties up to 12. And when I ordered it, they had a kit that said it included everything, and it was like $2 or $3 more. It was like $2.50 more. So I got that, and what they were doing with the kit, they gave you 2 capacitors, kind of a smaller one and then a medium one. And so on that simple diagram, in, out, ground, they just had these 2 capacitors in there. So I figured, well, simple enough, I've got plenty of capacitors. So what I did for this project, I had this, I think it's like a Christmas candy tin or cookie tin that I got. So a real quick rundown on how it works. Here's the input. It's reverse polarity, which means it sounds complicated, but it's not. It just means the center pole inside this, the connector, or the center of your adapter plug where you plug in, is negative. They always used to do it where the center would be positive, then they kind of changed it around. I think the Boss manufacturing company may have had such a rumor. I don't know who started that reverse polarity thing, and I blew up a lot of stuff before so yeah, it comes in reverse polarity, and then on the front you got 9 volt out, 9 volt out, 9 volt out, 9 volt out, 6 volt out, 5 volt out, 3 volt out. Then there's 2 12s back here, and the difference on the 12s is one of them is positive polarity. I do have some 12 volt stuff where the pin, the center connector where you plug it in, is positive. So it gets goofy. I mean, most pedals nowadays, it's always negative, and then like the real older ones are positive. So you don't want to mix those up. If you do, when you're running it off the same supply, what happens is the ground is connected when you plug in the cables. So if the ground, one side of the cable is coming in negative and the other side is positive, it's like the first rule of electricity. 2 things, plus and minus, don't mix them up. And that's like about all my theory. You ask me what Ohm's law is, I don't know, but if he was around today, he'd probably be furious with me. So, back to this device. Like I was saying, there's 4 ports for 9 volts. The 12 volt runs my amps. I usually run my homemade amps off 12 volts. So I can make splitter cables off of these. I could have one cable that comes out with 3 plugs on it, and with that math, I could run 12 pedals off of this. The thing about these voltage regulators, they do have an amperage rating. I believe for the 9s, it's 1 amp. Most effects, the analog ones like distortions and treble boosters and the simpler analog stuff runs between 15 and 30, maybe 60, I don't know, but low. Now your chorus flanger echo, your digital echo stuff, that's a little bit higher. And you know, the only other concern is with noise and things. I think those capacitors that I put in there, what they help to do is they filter out whatever hum or noise that you might run into. We'll have to see, you know. But I've got the input here, and then of course I fused it. I figured I'd probably be smoking some shit here, you know, crossing some wires over the hours. I'm monkeying with this stuff. And then in the front I put a little LED. There's a resistor on that LED. You always want to use a little resistor. You can go online and actually calculate the correct value. And that resistor runs off the 6-volt port. So, you know, if something is goofy, I'll be able to see right away. But how I constructed it, I can try to give you a little bit of a close-up here. The power would be coming in here. The fuse would be here. And so then it jumps over to that angled board that I'm touching right here. That basically serves as a main power bus. The positive and the negative hook up there coming out of the fuse, and then all of the other voltage regulators feed out of that and then to their respective jacks. And you can see how I used little fasteners. I screwed it down to the tin, so theoretically these things do generate a little bit of heat, you know, and I would imagine that depends on what they're powering. Like if they're just trickling out power, whatever you got plugged in as low drain, and it's just taking a little bit, or if you were like getting up there close to an amp and it was a hot day and you had stuff, you were running a popcorn machine, a toaster, a blender, a hair dryer, and an amp smasher off of it, you know, might melt the box. For my power supply, I do have a bunch of these laying around. It's a Hewlett Packard. I think it's for a printer, actually. It says 18 volts. How do you like that? I thought it was 16. 1.7 amp. So ideally, you know, I can take this thing when we go to the woods and we do little jam sessions at the Forest Preserve with little battery-powered amps, you know, and we don't want to disturb the wildlife too much. And we're horrible, too. But anyway, hopefully I'll be able to take this thing have like maybe a little larger gauge input cable with some nice clips on it, probably a fuse in there too. You always want to fuse stuff when you're going over 9 volts and it's, you know, a bigger battery, especially rechargeable battery packs. If you're going to mess around with any of that stuff, you definitely want to include a fuse. But yeah, I'm thinking just run the deep cell into here, and I've got, you know, I can take this to the woods too. So so far it's been fabulous. I've got a number of cables that I already had here that were pre-made, and I ordered a bunch of the jacks. These little jack connectors are real cheap, so I can make a few cables, and I can make some splitter cables branching off, and I could do a couple reverse polarity if I need +9, because they're all negative outputs. Center conductor is negative. I could just flip-flop them when I solder them, and then put some identifying marker like red shrink boot on it, or, you know, purple, something like that. If you want to look into this a little more, I know that there's guys that do it properly. I wouldn't recommend you trying this. It's a dangerous project. There will be severe repercussions if you plug this in instantaneously. Probably like a brownout over one of the coasts, probably the opposite one, and then some flatulence. But in any event, if you want to learn how to do this right, you could Google the spider. I think Aaron Nelson or R.G. Keene, one of those guys that these guys know what they're doing. They're not like me. But he's got a nice diagram for a do-it-yourself unit that I think it includes more components and safety measure, and it's probably going to work a lot better than this one. So, or you could, you know, run out and get a Voodoo Labs pedal power if you're doing this professionally and you can afford. I think they're, you know, $300 for that unit, which is just out of the question for me. But thank you for joining me here in Fuzz Lab. I really appreciate all the views, and I wish you guys all the best luck with your projects and whatever you may have going on. Keep on hacking.